So what's a myth you'd like to dispel about AI and ML?
The myth that I would like to dispel for those sort of, right down the middle, brick and mortar businesses that think that AI and ML are sort of out of reach or not applicable to them, I would challenge and encourage them to sort of, forget about AI and ML for a second. Do you have data? Do you have questions about that data? And can the answers to those questions give you a competitive advantage? Can they make you more profitable? Can they make you more operationally efficient? And if the answers are yes, and they're yes to a degree that makes sense to get those answers, then I would really encourage and challenge businesses to leverage ML to extract those answers from the data, because the answers are in there and ML can find it.
So what are the current big bets in AI ML innovation?
Sure, so I think there's a lot of theories and ideas out there about what are the big bets, but I think if we look at what's really interesting right now, all the really cool projects that we see on Reddit and YouTube, right? Those are, the center of gravity of how those are being implemented are mostly deep neural networks, right? And so there's two particular implementations of deep neural networks that I think are really interesting. The first are genetic algorithms. So without getting too deep, if we look at a standard deep neural network, like one that we'd use for image classification, it's going to have a fairly standard architecture, canonical architecture. And by architecture for deep neural network, we mean, it has layers, some of them are connected, some of them are not connected, the number of nodes per layer, et cetera. And the only thing we're going to change about that when we're training is the weights between the nodes, right? The architecture is going to remain fairly static. Contrast that with genetic algorithms. Genetic algorithms actually kind of randomize the architecture, and that is part of what we change while we're training, and it does it in a way that models human genetic, sort of the way that we mutate as a society, right? So what'll happen is we'll train the model, we'll use a fitness function to determine how well that model's doing, and then we'll take a certain number of the best performers and we'll breed those, add some mutation, just like we have with human genetics, and then eventually we'll get a really effective architecture for the deep neural network. And what's really cool about it is when you look at a standard deep neural network, it looks like a building or a bridge or something that a human would build. When you look at a deep neural network that's been designed through a genetic process, it looks crazy, right? It looks like a brain, completely random. So that's really interesting. And there's a lot of really cool work being done there. But really most of the really cutting edge stuff that gets a lot of attention right now are GANs, and these are generative adversarial networks. I know it's quite a mouthful. And what GANs do is they basically take two neural networks that are highly specialized and they pit them against each other. So we've got a generator that does the standard work of a neural network, whether we're doing classification or trying to create images that look like real human faces or whatever. And then we have this discriminator, right? And the discriminator, his job is to sort of test the work that comes out of the generator. Now the discriminator knows what real paintings look like and what real forgeries look like. And so whenever the generator loses, the discriminator wins, and vice versa. And so now we have these two networks that start out very dumb and not very knowledgeable about either themselves or the problem space, but as they evolve through training, they both get very good at producing the content and judging the content. So this is where really all of the really cool and almost scary AI and ML research is coming out of GANs right now.
Awesome, thanks Eric.